Hello, we are here at the Orlando Regional with Team Resistance, Team 86. We're going to be going over their very unique robot designed to play REEFSCAPE in a way we haven't quite seen anybody really tackle today on Behind the Bumpers. All right, Victor, you wanted to go over some of the design philosophy behind why you made these decisions.
Yeah, of course. So at the beginning of the season, we realized that since the source was so close to where we were scoring, we wanted to maximize efficiency on cycle times. For coral specifically. So we built a robot with this in mind. So everything from the mechanical design to the programming aspects are centered around making this repeatable and efficient, and it's just worked out great for us. So we can start over at our control scheme. So here's where we all started. So here is our co-driver's button box. The co-driver has inputs that select the level that where we want to score on and at which branch we want to score on. These inputs determine where the robot will go, and we will generate trajectories to go to these branches automatically. All the driver has to do is hold down buttons for either the reef or the source to determine whether they want to score or pick up coral. This allows us to be efficient and repeatable, and our mechanical design reflects the rest of this philosophy.
All right, very cool. And Ari, if you want to go over more of the design fundamentals of the robot?
So like Victor said, we wanted to start with picking up from the source, and we found a horizontal intake was one of the best ways to do that. So Aryan, if you want to enable to show how our horizontal intake works. As soon as the coral falls in, we use two banner sensors that trigger these fingers, which slide in and trap the coral inside. The reason we went with the horizontal intake was because when we go to score, B, Victor, it gets us extension outside of the bumpers, unlike anything else. Moving past that, we also have a pneumatic elevator, which we used because of its simplistic coding. That's also true with our entire robot, as everything is pneumatic except for our swerve drive base. Moving on to the climb, we knew the climb would be very unstable with the chain. So we decided to make a little funnel to trap the cage and bring it into our climb sequence, or into our climber. Our climber's width is the exact width, or just a little bit more than the exact width of the cage, which keeps it square. After it's come in underneath our bucktooth, which was added to prevent the cage from sliding out after we climb, and that happens because this is at an angle. After we've trapped it, these four neodymium magnets control the top of the cage, while this plate in the bottom controls the bottom, which allows us to climb very effectively and with the complete control of the cage. Once we have control, this cylinder back here, the cylinder back there pushes over a mechanical latch, and then two 150-pound gas struts take over. These two black ones right there. The screw here is solely for safety and is used in the pits or when the robot's moving. That way nobody's fingers or other stuff gets hurt when we don't want the climber to get activated. Yeah.
All right, very cool. Can we see that elevator in action?
So all we have to do is hit the button.
We also have this tongue here which clears algae. It's a small piece of material, but its functionality has helped us a lot with our scoring. Our first iteration of this was solely a piece of rubber that was attached to the left side of our coral dropper. However, we found that would hit the pole and it wasn't a good spot. So we moved it down here, but then it didn't have enough pressure, so this little piece of polycarbonate was used to get the right amount of pressure and the right amount of grip.
All right, very cool. And Aryan, you wanted to go over just some more stuff?
Yeah, so one of the most important aspects of our robot was like automation. Like you saw Victor over here, when he was aligning to the April tag and trying to score a coral, he did it all with a single press of a button. He was just holding down a trigger and it did the entire sequence. So to accomplish that, we had to use 5 RG cams scattered across the entire robot, essentially giving it like a 360 field of view. There's one purple one right here, and then 4 that are on the turn steering motors of each module. And these were modeled in CAD, and like we found the exact for example, angles and like degrees necessary so that we could get as much APOTAG coverage as possible. And that gives us full field localization using photon vision. So with each of these cameras running at 30 FPS, you can come over here and see actually on Advantage kit that right now we moved the field, like the reef all the way outside, but you can see like this is a live update of our robot according to just a single APOTAG. Now with 22 APOTAGs around the entire field and a 360 field of view of everything, full field localization is possible. Right, so along with that, as you saw here, this is Advantage Kit, which saves all states, all like actions and everything about the robot, which we pull onto USB drives. And going into the actual mats, we have autonomous pats that happen, like right after autonomous where pats are generated. Since the driver wants to be able to automate this as much as possible, holding down a single button actually auto-generates pats in the middle of like practice, which you can see in like green lines which appear across movement. So if they like just hold down a button, it automatically figures out where to go and then does the entire sequence of putting coal up. And the same applies for picking up coal and even climbing, which is our end stage, where it drives all the way over to the selected cage.
All right, very, very cool, very, very unique. You guys truly embody your motto of going against the current. Nobody looks like you and nobody came up with the same ideas that you guys did. It's very unique and it's a very cool way of designing a robot. Thank you guys so much for the interview today and good luck at the rest of the regional. This is James with Behind the Bumpers signing off.